Hello everyone. This video will be going over adding and subtracting radical expressions. Okay. Now the one thing you have to remember about adding and subtracting radical expressions is that overall it's similar to adding or subtracting variable terms. Okay, so if you can add or subtract variable terms, you can add or subtract radical expressions. Okay, so for example, if you have 3x plus 2x equals 5x, it's the exact same thing. You have 3 square root of 2 plus 2 square root of 2. As long as your radicals are the same, that would be 5 square root of 2. Okay, but remember, they have to be exactly the same, index and all. Okay, so for example, if you had to simplify, say 6 times the cube root of 2r minus 2 times the cube root of 2r. Okay, so if go ahead and rewrite it. Okay, so 6 times the cube root of 2r minus 2 times the cube root of 2r. Your radicals are the same, so you just get your 6 minus 2, which is 4 times the cube root of 2r. Okay, you can only combine them since they're both the same. Now, if you had, let's say, for example, you wanted to simplify 7 times the 4th root of 15 minus 3 times the cube root of 15. Okay, so if you notice here, you have the 4th root and the cube root, which means your indices do not match. The index of your first term is different from the index of your second term. Even though the 15 is correct, everything has to be the same in order to combine them. If you notice in this example, both have an index of 3. Both have a radicand of 2r. They're both exactly the same. That's why we could combine them. These two are not exactly the same, so we can't combine them. Okay, so we can't combine terms since the 4th root of 15 and the cube root of 15 are not exactly. That's the key word there. Exactly the same. Okay, so your simplified answer would just be that answer. So you have 7 times 4th root of 15 minus 3 times the cube root of 15. Okay, so this is actually your answer, since it can't be simplified anymore. Alright, so let's go to our next example. Okay, now our next example, you remember the power of a product. So if you have x times y to the power of m, that's equal to x to the power of m times y to the power of m. Okay, so if you think about it this way, let's say you have x times y to the 1/2 power. which is equal, remember we just distribute that exponent, so you have x to the 1/2 power times y to the 1/2 power. And if you remember, square root of x is equal to x to the 1/2 power. So this will be square root of x, this will be square root of y. So that's square root of x times square root of y. So that means x times y to the 1/2 power is just the square root of x times y. Okay, so square root of x times y is just equal to the square root of x times square root of y, which means square root of 3x is just square root of 3 times square root of x. Okay, so that was in our last video. Just wanted to give you a little bit of a refresher, because that will be very important. Okay, so for example, if we wanted to simplify square root of 75 minus square root of 27. Okay, so if you remember from our last video, you want to try and get both of these to where you have a perfect square. So the first thing you want to notice is that 75 is equal to 25 times 3. Okay, so that gives you a perfect square. And also 27 is equal to 9 times 3. Okay, so both of those, you notice, have your perfect squares. Okay, so we're going to break this down one step at a time. Okay, so you have square root of 75 minus square root of 27. Okay, so we see here, square root of 75 can be square root of 25 times 3. So that's a square root of 25 times 3 minus 27, which is square root of 9 times 3. Okay, so just like up here, when you have the product under a root symbol, you can separate them. Okay, so that's square root of 25 times 3 minus square root of 9. Sorry about that. Times square root of 3. Let's clean that up a little bit. Times square root of 3. There we go. Okay, so all we did was get our 25 times 3 and separate it. Now 9 times 3 and we separate it. Okay, so even though square root of 25 is plus or minus 5, we're just going to do the plus sign for this one. So since square root of 25 is 5, that's 5 times square root of 3 minus square root of 9, positive or negative 3, but we're just going to look at the positive. So you have 3 times square root of 3. Okay, so you really don't have to put the multiplication symbol there if you don't want to. You could have just went straight to 5 square root of 3 minus 3 square root of 3. Clean this up a little bit. There we go. Okay, now if you look at it, your radicals are both the same. So you can combine those two. So that's going to equal 5 minus 3 is 2, so you have 2 square root of 3. Okay, so square root of 75 minus square root of 27 simplifies to 2 square root of 3. Okay, so just one step at a time. That's the best way to do it. All right, so let's go to our next example. Okay, so let's say, for example, if we wanted to simplify, say 18 plus 2 square root of 12 minus 3 square root of 48 plus 9. All right. I'm just going to rewrite it. 18 plus 2 square root of 12 minus 3 square root of 48 plus 9. The first thing I'm going to do is notice that we have two whole numbers here. So I'm just going to go ahead and combine those. You don't have to do that first. You can do that last. You can do it towards the middle. It doesn't matter. Okay, you'll still get the same answer. I just chose to go ahead and combine those two now just to get it out the way. Okay, so 18 plus 9 is 27. So you have 27 plus 2 times square root of 12 minus 3 square root of 48. Okay, so let's look at our 12. Okay, so we know that 12 is equal to 4 times 3. Okay. There's also 6 times 2, but 6 is not a perfect square, and 2 is not a perfect square. Well, 4 times 3, we have a perfect square. Okay, so that means square root of 12 is equal to square root of 4 times 3. Which means we can separate those two. So you have square root of 4 times square root of 3. Square root of 4 is equal to 2, so that is equal to 2 square root of 3. Okay, so we have our 27 plus 2. Remember, square root of 12 is equal to 2 square root of 3 times 2 square root of 3. Okay. Now we do the same thing for square root of 48. Now 48 is 12 times 4. There's also 16 times 3. We're going to use 16 times 3 because that's the larger perfect square. But you could have used 12 and 4 also, and I'll show you that a little bit later. So 48 is equal to 16 times 3. Okay, so that means square root of 48 is equal to square root of 16 times 3. Okay, so if we go ahead and separate those two, that's square root of 16 times square root of 3. And square root of 16 is equal to 4, so you have 4 square root of 3. Okay, so this becomes minus 3, and square root of 48 is 4 square root of 3 times 4 square root of 3. Fill that in. Okay, so now we go ahead and multiply these 2's and this 3 and the 4. Okay, they're just, it's kind of like saying 2 times 2x will be 4x. So 2 times 2 square root of 3 will be 4 square root of 3. So you have 27 plus 4 square root of 3, if we go ahead and multiply these two, minus, if we multiply these two, we have 12 square root of 3. Now, since these two roots are equal, we can combine them. So we end up with 27 minus, if we combine these two, 4 minus 12 is 8, negative 8, so minus 8 square root of 3. Okay, so that would be your final simplified answer. Now, going back to the square root of 48, just to show you that if you did start off with 12 and 4, you'd get the same 4 square root of 3. So let's say square root of 48 is equal to square root of 12 times 4. So that's going to equal to square root of 12 times square root of 4 if we separate them. Okay, so we know square root of 4 is equal to 2, so that's 2 times square root of 12. We're just kind of switching those around. So you have 2 times square root of 12. Okay. Now if you remember, 12 equals 4 times 3, which means you can simplify this a little bit more. So you have 2 times the square root of 4 times 3. So if we separate this one again, we have 2 times the square root of 4 times the square root of 3. Here, square root of 4 is equal to 2. So you have 2 times 2 times square root of 3. So if we combine these two, you have 4 square root of 3, which is the same answer you have up here. Okay, so it doesn't matter which perfect square you start with, but if you start with the largest perfect square, you don't have to go through all these extra steps. Okay, so a lot of times it's just easier to go through the largest perfect square that you can factor from your number. Alright, so let's go to our next example. And if I can separate this paper, there we go. Alright, so let's say if we have, let's move that over a little bit, there we go. We wanted to simplify, say, the cube root of 16x to the 4th power plus, I'll clean that up a little bit. There we go. Plus 4 times the cube root of 27x to the 3rd power minus x times the cube root of negative 128x. Okay, so now, if you notice here, we're looking for cube root values. Okay, so first thing we're going to want to notice is that 16, there's no cube root value for 16, but 16 can equal 8 times 2. And we chose 8 times 2 instead of 4 times 4 because we know that 2 times 2 times 2 equals 8, which will give us our cube root value. Okay, same thing with negative 128. That's going to equal negative 64 times 2. Okay, and why do we pick negative 64? That's because negative 4 times negative 4 times negative 4 equals negative 64. Okay, so they both have cube root values. Okay, so same thing with 27. Three times 3 times 3. That one we have an actual cube root value for. But these two we have to settle for kind of a cube root factor instead of the whole thing being a cube root. Alright, so we're going to go ahead and rewrite it. So we have the cube root of 16x to the 4th power plus 4 times the cube root of 27x to the third power minus x times the cube root of negative 128x. Okay, so if we replace 16 with our x times 2, we have the cube root of 8 times 2 times x to the fourth plus 4 times the cube root of 27 times x to the third. I'm just going to leave that there for right now. Minus x times the cube root of negative 64 times 2. Oh, got my times x. There we go. Okay, so now we can go ahead and separate these. Okay, the same way you could separate 2, you can do the same thing with 3 factors. And just separate those into 3 separate cube roots. Okay, so we have the cube root of 8 times the cube root of 2 times the cube root of x to the fourth power. Okay, so all we did was separate that. Plus 4 times the cube root of 27 times the cube root of x to the third power. Okay, so we do the same thing here. Minus x times the cube root of negative 64 times the cube root of 2 times the cube root of x. Okay, so we know that the cube root of 8 is 2. Since 2 times 2 times 2 equals 8, the cube root of 8 is equal to 2. Okay, so we have 2 times the cube root of 2. You can't really simplify that anymore, so we just leave that as the cube root of 2. Okay, now the cube root of 4, this is where it gets a little bit tricky and you have to be careful. We're going to put that right down here. So the cube root of x to the fourth power, we're going to make that equal the cube root of x to the third times x. Let me clean this up a little bit, make it a little bit bigger. Cube root of x to the third times x to the first power, or just x. Okay, so if we separate these two, we have the cube root of x to the third power times the cube root of x to the first power, or just x. Now, if you remember, when the exponent and index are the same, they cancel each other out. So this is just x times the cube root of x. X times the cube root of x. Okay, so times x times the cube root of x. All right, so that's how we were able to simplify that one. Okay, so plus, say 4. We know the cube root of 27 is equal to 3, since 3 times 3 times 3 is 27. So times 3. And for this one, remember, when the exponent and the index are the same, they cancel each other out. So this is just x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the cube root of x. Okay, so times x times the c So minus x. And you have the cube root of negative 64 is negative 4, because negative 4 times negative 4 times negative 4 is negative 64. So times negative 4. And you have cube root of 2, which is still cube root of 2. Can't really do anything with that one. And you have cube root of x, which is still cube root of x. Can't really do anything with that one. Okay, so we're slowly but surely moving along on this one. Okay, now if you remember, that the nth root of a times b is equal to the nth root of a times the nth root of b. Okay, we've used that over and over again. But remember, it goes in both directions. If you have the nth root of a times the nth root of b, you can combine those two under the same radical symbol. Okay, which is exactly what we're going to do here. Since these two have the same radical symbol, you have cube root of x, cube root of 2, we can combine them. Okay, so that gives us 2 times the cube root, oh, forgot the x there. I like to put the x out in the front, so 2 times x times the cube root of 2 times x. Okay, so you think of it this way, like 1 times the cube root of 2 times x, and then you do the x times 1, and it combines those two. Okay, so now if we go to this one, you just have 4 times 3, which is 12, so you have 12 times x. Okay, so you have minus and the negative here, so that gives you plus 4 times x, so that's plus 4x. Then again, if you combine those two, you have cube root of 2 times cube root of x. You have the cube root of 2 times x. Or you can just make it 2x if you want to. Okay, so if we go ahead and simplify those, you have 2x times the cube root of 2x plus 12x plus 4x times the cube root of 2x. Okay. Now if you notice here, you have cube root of 2x and cube root of 2x. So you can actually combine these two. Well, actually it's x2x and x2x. Okay, so you have 2x cube root of 2x plus 4x cube root of 2x. 2x and 4x is 6x. So you have 6x cube root of 2x. Oh, move that up a little bit. Plus, don't forget your 12x right here. Plus 12x. Okay, so as you can see, each individual step is not bad. It's just keeping them in order from beginning to end. If you keep a step-by-step order to everything that you're doing, you should end up with the correct answer at the very end. Okay. So the best thing to do is try not to rush through it, and again, just go step by step. Okay, the more you practice, the faster you'll become. All right, so let's go to one more example. All right. So, for example, let's say if we wanted to simplify. say the fraction 5 over 6 times the square root of 45x to the 4th power plus 2 times the square root of 20x to the 4th power. Okay, so of course you're going to look at your 45 and your 20, and the first thing you want to notice is that 45, and since we're just looking for square roots, we're going to look for a perfect square. So that's 9 times 5. And same with 20. You can use 10 times 2, but no perfect square. So 20 we're going to make equal to 4 times 5, where we have our two perfect squares. All right, so starting off, I'm just going to rewrite our problem. So we have 5 over 6 square root of 45x to the 4th power plus 2 square root of 20x to the 4th power. Okay, so if we go ahead and substitute our 45 with 9 times 5, that's 5 over 6 times the square root of 9 times 5 times x to the 4th power plus 2, replace that with 20 with 4 times 5, square root of 20, square root of 4 times 5 times x to the 4th power. Okay, so now we have them all factored out, we just separate them. So we have 5 over 6 times the square root of 9 times the square root of 5 times the square root of x to the 4th power. I'm going to show you a neat little trick with that x to the 4th power. Plus 2 times square root of 4 times square root of 5 times square root of x to the 4th power. Okay, so that x to the 4th power, this is a little trick I'm going to show you. So x to the 4th power, you can actually rewrite that as x squared squared. Okay, remember 2 times 2 is 4, so that will give you x to the 4th power. So that means that square root of x to the 4th power is equal to the square root of x squared squared. All right. So remember also that when there's no index, it's assumed to be a 2. So if we rewrite that as the square root of x squared squared, this exponent cancels out with that index. Or you can use this exponent and that index, doesn't matter. I just use the one on the outside. Okay, so those cancel out, and this is your answer, which is x squared. Okay, so that gives us 5 over 6 times square root of 9. Remember, it's positive or negative. We're just going to use the positive, so that's times 3. Times square root of 5. I'll just keep using, I don't want to switch up between parentheses and anything else, so I'll just use the times 3 times square root of 5. Remember, the square root of x to the 4th is x squared. So that's times x squared plus 2 times square root of 4 is 2 times square root of 5, since it's not a perfect square, times square root of x to the 4th, which is x squared. Okay, so if we go ahead and combine these two, and combine those two factors, okay, 5 over 6 times 3 that becomes 15 over 6. Okay, because remember it's 5 over 6 times 3 over 1. Okay, and that x squared, we're just going to move it up to the front. And you have square root of 5 plus 2 and 2 is 4, so we have our 4. Again, we're going to move our x squared to the front. And we have our times square root of 5. Okay, so if you notice, you have x squared square root of 5 and x squared square root of 5. Okay, so both our variables and our radicals match. So we can go ahead and just combine these two. Okay, so just solve that over here. So we have 15 over 6 plus 4. So 15 over 6 instead of plus 4, make that 4 over 1. So to get our denominators to match, we multiply this one by 6 over 6. So we have 15 over 6 plus 6 times 4 is 24 over 6, which is equal to 39 over 6. Okay, remember 39 is equal to 13 times 3. And 6 is equal to 2 times 3, where anything divided by itself is 1, so those two cancel out. So you end up with 13 over 2. So after combining these two, you end up with 13 over 2 x squared square root of 5 as your final simplified answer. Okay, so I know it's a bit lengthy, but if you take your time and find a process that works for you, you should be okay. Just takes a little bit of practice. All right, hopefully this video was clear, and I will see you on the next one.